All right, welcome to the Going Ballistic podcast with Ryan Kleckner. I'm Ryan. Sorry for the echo you might hear in the background. I actually moved into my new building. It's pretty exciting. I have a full gun shop now, so I can get running with the rifle line even faster. And I even have a separate section just for recording studios. So once this all gets set up, I'll be able to hopefully do more podcasts, but I'm also going to be able to have the video channel up and running. I'm just deciding now how I'm going to set everything up and getting the equipment in. So if you're looking forward to that, great, stay tuned. If you're not, well, I guess you could just ignore it. So don't worry about it. There's a couple new news items. I raffled off the rifle that you guys may have been following along with, the El Cheapo. It was Jason, my cousin, and I's contest to see who could build the absolute cheapest AR-15 sourcing commercially available parts, and ended up winning for $380 something to have a fully functional AR-15. But it is cheap, and the best way to describe how it looks is obnoxious. It's pretty rough, but it worked, and that was the point of the goal, and it was a fun build. As promised, I raffled the rifle off for charity, so we raised some good money for charity. I appreciate that, everybody. On my Facebook page, everyone that entered had a good chance. We had some good banter back and forth. That brings up a good point. If you don't know about my Facebook page yet, even if you're not on Facebook yet, you should consider it, because everything's starting to go there now. I have a page that is just facebook.com /Kleckner.co, where you can just search my name on Facebook. I'm sure you'll find it, or you can find the links on my websites. And on there, you'll find much more updates and information about things like this raffle. I ran the raffle actually in Facebook, so you could enter that way. And we had a winner. So Adam won the rifle. It's already been shipped off to his FFL, and as far as I know, he's already even transferred it to himself and picked it up. He put a post on the Facebook page I'm talking about, and I've challenged him to get some pictures and some feedback for us up there about if the thing still works by the time he got it, which I hope it does. These podcasts can be found on the podcast website, which is goingballisticpodcast.com. And you can add a / and the show's number to find details about the show. Since this is the 16th show, you can find goingballisticpodcast.com / 16 as in 16 as in the number. And you'll find the notes and the links and everything I'm talking about. Now, don't get too hooked on that website. I'm about to shut that down, I believe, and consolidate everything in together. The website's not up yet. I shouldn't even mention it, but it's going to be kleckner.co. That's going to be the website for articles, blogs, podcasts, rifles, books, everything all in one house. As I'm learning my way through how to do all this stuff, it makes a lot more sense not to have everyone going to 5 or 10 different websites and have it all be the same place. So eventually I'll consolidate it, but I will leave breadcrumbs behind, for links or trails for you guys to be able to find yourself all to the main one site. But for right now, goingballisticpodcast.com. The other bit of news I have is Hornady is having me in their booth at SHOT Show to sign some books, which just completely flattered, excited about. It's going to be on Wednesday from 10 a.m. to 11 a.m. local time. I'll be in the Hornady Bullets booth signing copies of the book, and I'm bringing a limited amount just because I don't want to have a pallet of books show up. But I hope you guys show up if you're going to SHOT Show, or you stop by and at least come and say hi and shake my hand and get a chance to meet you. I'd sure would like to meet some of y'all out there. And if you want an autographed book, I'm going to be doing that in exchange for a donation to charities. And I'm hoping we can get the Special Operations Warrior Foundation and the Sua Sponte Foundation to be there. Once I told them about the book signing, they're both super supportive, super excited, and said they're going to try and make it there with some swag for you guys to give out. So if you get a chance, go check it out. So this podcast, I'm saving some of the questions I'm getting via emails. You guys are doing great. Keep sending in questions via email. The problem, though, is I'm getting this email inbox folder that is just getting stuffed with podcast questions. So I have podcast ideas for the next 50 podcasts, I'm sure. So I'm sorry if I don't get to your guys' questions you send in fast enough. But I know that if I take the time to answer each one via email, then I won't have anything to talk about on the podcast either. So be patient. I'll get to it, or I'll save some of those ideas for future books. But one of the things that's come up a lot lately that I'm going to address in this podcast is shooting at angles. Now, I wrote an article for Recoil Magazine, and they posted the article in full, which is really cool for Recoil to do. They normally just do the preview because they want you to buy their magazine. But they posted a link to the entire article, and I'll put the link on this show's notes so you guys can go read it if you want and see some of the cool pictures. As a hint, the rifles that you see in the pictures in that article in Recoil it is a prototype of the rifle I'm going to be coming out with. It is not mine. It is put together by some awesome folks that I'm working with, and that was just something they sent me to see what it was going to look like to do a mock-up. So if you like the look of that, good news. I'm going to have one available hopefully in a few months. We'll see how that goes. So, but Angles has come up also, by the way, on another podcast, which I won't bring up yet, that has asked me to come on, and I've done a couple episodes with them already in the bank. And this is one of the topics we talk about. So, hot topic for some reason. Let's cover it now. So, shooting at angles. What do I mean by that? I'm referring to shooting mostly up or downhill. If we have time in this podcast, I'll get into what happens when your rifle's actually at an angle, meaning tilted either left or right or canted. But for right now, we're just going to talk about shooting up or downhill. So that makes an effect on your bullet. It changes it. Right about the time you get good at figuring out the flat ground and you start figuring out the environmental effects, the wind and the air density and things like that. Now I'm going to throw this curveball to you and let you know that the up or downhill actually matters too. So here's the best way to think about it. You all have heard me talk about that of all the external variables on a bullet, the easiest to account for is the biggest effect on the bullet. So that's good news for us. That's gravity. And it's the easiest to account for because it's effectively the same. So we can figure out what our bullet's going to do, how far it's going to fall when it travels 500 yards. And when we shoot 500 yards again, we already know how far it was going to fall, and we can rely on that in the future. Now, of course, there's going to be changes in the environment that will affect how far it falls because it'll affect the time of flight of the bullet to the target. However, for our purposes, let's just assume that every variable is the same for environmental stuff, or else we'd have to be juggling so many variables at once. It'd be hard to figure out. So assuming the same conditions, you're shooting at a target flat away from you, and then you're shooting at a target from the same position, you turn and you start shooting downhill, you will have a different impact for your bullet based on the angle. So the bullet is affected by gravity the most when you're shooting flat across the ground. So when the bullet is traveling along with the surface of the earth, which means gravity is pulling straight on the side of the bullet. It's pulling it directly off its path the most. Well, gravity is going to affect the bullet least when you're shooting either straight up or straight down. Now, I don't mean to say that gravity's not affecting the bullet or that somehow it's avoiding gravity. That's not true. So gravity is a force that is felt by the bullet. I guess if the bullet had feelings. Gravity acts on the bullet regardless of where it is in space. There's gravity. Even in the far reaches of outer space, there's always gravity somewhere. So I'm not saying that. What I'm saying is the effect of the bullet. So the effect off of its original path. Because that's what we're worried about, right? We're worried about the original path where we're looking at the target and the bullet leaves and then it starts changing off that original path. We need to measure that so we can compensate and get a hit. Well, the original path effect, horizontal, biggest by far, because it kind of makes sense if you just think about it. If gravity's pulling straight sideways on the path, then it's probably going to pull it off the path the most. Where if you're shooting straight up or straight down, precisely straight up or straight down, your bullet's actually not going to deviate off of the path at all. Gravity's still there, but gravity's not going to pull it off of the path. So think about this, for example. Think about you're sitting on the edge of a cliff, and you're going to shoot straight down. Straight down below you to a target 500 yards away. Do you think that bullet is going to change, fall off of, deviate from its original path all the way to that 500-yard target the same as if you're shooting across flat ground? No, definitely not. You're shooting across flat ground. For a 308, you're going to need about 12 minutes of angle of elevation because the gravity is going to pull it off that path. But if you're shooting straight down, that bullet is going to travel in a straight line all the way to the bullet. It's not going to drop at all. You're going to have a very different result between those two targets. Well, now imagine taking a target that's not straight below you, but instead is I don't know, 20, 25 yards away from the base of the cliff. So it's not straight down, it's mostly down, but a little out. Well, I hope you can just imagine that the bullet is now going to fall a little bit off of the original path. Not much, but it's going to fall off a little bit. Surely not near as much as it would fall off if you're shooting straight horizontal across the ground, but it's going to start to move. Well, the further and further we get out away from the base of the cliff, the more and more the bullet is going to fall off of its original path, all the way up to the maximum of horizontal. So, how do we calculate that? How do we figure that out? That's the big thing that matters, right? So who cares that it affects it, really, as long as I can just tell you what to do? Well, what you need to do is figure out how much the bullet is traveling across the surface of the earth. So let me qualify that. If you're shooting 500 yards away across flat ground, that bullet is traveling 500 horizontal yards. It's covering 500 yards of the surface of the earth. But if you're shooting straight down off the cliff, it's not covering any ground. It's not even covering an inch horizontally. It's going straight the full 500 yards of the target. But if you're picturing the ground, it's not going side to side at all. And therefore, you would treat it as if you were shooting 0 inches away from you. You would have no elevation adjustment at all. And if you're shooting 25 yards out from the base of the cliff, well, you pretend like you're shooting a target only 25 yards in front of you. That's how you figure it out. So no matter what you remember from this, if you're just going to remember one thing, remember this. When you shoot at an angle, the bullet is not going to fall as much as if you're shooting across flat ground. Which means, if you ignore the angle, and you're shooting out and you're out hunting and you forget to compensate for the angle and you shoot at the target, if it's far enough away, and if the angle is steep enough, you might miss completely over the target, because when you adjust it up for the elevation, you were expecting your flat ground. You were going for that predictable information that you're used to using. And now when the bullet doesn't fall as much, you will have adjusted up too much, and therefore you will have sent the bullet potentially right over the target. So this does not just work going downhill. It's the same shooting uphill. That might be the hardest thing for you to believe when you hear this, but it is true. Uphill and downhill has the same effect when shooting at an angle. Now, most people wonder, how is that possible? It goes downhill, the bullet's going with gravity. When it goes uphill, the bullet's going against gravity. Well, you're right. But the bullet is going so fast that even though you're right, there is a difference, it's not anything we're going to measure or worry about as far as the effect, of what's going to happen when you're shooting at that angle. So, I've told you that the way we figure it out is by looking at the horizontal distance, 0 yards, 25 yards, 200 yards, 500 yards, and treating the target as if it's only that far away. So even though I'm looking with, let's say, a laser rangefinder from my eyeball all the way to the target at a full 500 yards, if it's only, 200 yards away from the base of the cliff, which means the bullet is only going to be covering 200 yards across the surface of the earth, even though it's flying a full 500, because it's only covering the 200 yards across the surface of the earth, I treat it like I'm shooting a 200-yard target. Here's the problem. We're not always shooting on cliffs where we can get down there and measure exactly how far away from the base of the cliff the target is. We don't necessarily know, or you can't just tell by looking at a target, what that horizontal surface of the earth, however you want to think about it, distance is going to be. Instead, we've spent most of our time figuring out how to get the distance from our eyeball to the target, either using a laser rangefinder or milling the target or doing something like that. We can get that straight line distance, but it's really hard to just visualize, because you can't, that horizontal distance. So the way we figured it out is with a little bit of trigonometry. And I'm sorry to geek out on you a little bit here, but this is part of the fun of shooting long range, and I think this style of shooting is the math and the geekiness a little bit. So let's figure this out. So there's trigonometry that can let us know what that horizontal distance is, but we have to pretend that we have an imaginary triangle. So go back to that cliff. You're sitting on the edge of the 500-yard cliff. You're looking straight down. Let's draw an imaginary line from you all the way down to the base of the cliff. So a straight vertical line. And that's going to be one side of the triangle. Okay? Now, at the bottom of that cliff, let's pretend it's a 90-degree angle. The cliff is straight up and down from the ground. And then as the ground goes out to that target, a couple hundred yards away, that imaginary line that you can draw from the base of the cliff out to the target is going to be a perfectly horizontal line. that's going to be a side of the triangle. So you have a perfectly vertical line from you to the base of the cliff, and you have a perfectly horizontal line from the base of the cliff out to the target. Well, now if you connect with an imaginary line from your eyeball to the target, that diagonal line makes the third side of the triangle. If we use that triangle for the basis of our calculations, we can figure this out. Now, the three sides of the triangle also have three corners, right? So we have an angle or a corner of the triangle up where you are at your shooting position. The corner is made by that imaginary vertical line and that diagonal line. You have a corner down at the base of the cliff, right? Where the vertical and the horizontal line meet. And you have a corner of this imaginary triangle out at the target. And that corner is made by that diagonal line up to you and the horizontal line back to the base of the cliff. So I hope you all can picture and follow along with this. Well, by using some trigonometry, if we know that diagonal line length, so that diagonal line is called the hypotenuse of a triangle. I don't know why I just told you that. Forget about it. The hypotenuse, if you know the length of that side, that diagonal line, and you multiply that length by the cosine of the angle at the target, you can figure out that horizontal distance. So that angle that is made by the target there, which again is the corner made by the horizontal line and the diagonal line and the horizontal line, that angle, if you take the cosine for that angle and multiply it by that diagonal line, you get the straight line. So it's kind of a neat way of figuring out the adjoining line or the two lines for that corner to figure out that distance. Well, the cosine, there's no way for you to know except you just memorize it or write it down or have it with you. So for example, the cosine of 30 is 0.866. That's essentially like saying if you're dealing with a 30-degree angle, the horizontal distance is going to be 86.6% of the diagonal distance. And that makes sense. The diagonal line always is going to be longer. In that imaginary triangle you have in your head, just picture that diagonal line folding down and laying flat. It's always going to be longer than that horizontal line. The cosine for 10 degrees is 0.984. And I'll put this table for you guys so you can see all the cosines on my website. Or if you have your iPhone calculator, you can pull it out and hit the scientific button, and it'll have a cosine button. You can type in 30 cosine 10, and it'll do the math for you if you have a 30-degree angle and figure out the cosine. But what we do is we use that cosine, and it gives us that horizontal distance. Now, sometimes it matters, and sometimes it doesn't. I just told you all this math and how to do it. But if you're shooting, for example, 100 yards away, and it's a 5-degree angle, the cosine is 0.999. That means if you took the angle into account, you shouldn't shoot the target like it's 100 yards away. Instead, you should shoot it like it's 99.9 yards away, which, by the way, is the same thing. And if you disagree with me and you say it's a big difference, great. Pull out your dope book and show me what your dope is for 99.9 yards. I bet you don't have it because it's going to be the same as it is for 100. So don't worry about it. But you get out far enough. You get out there 500 yards with a 30-degree target, you can have a big difference. You can completely miss and shoot over the target. So, for example, let's say you have a target that's 800 yards away. You're up on a hill and you're looking at a target, use your laser rangefinder, you see it's 800 yards away. And you have a 30-degree angle. Well, I already told you that it's 0.866. So you take the 800 yards times 0.866 and you get a horizontal distance of 693 yards. That's huge. The elevation data you have on your rifle for 690 yards versus 800 yards should be enough that you might completely miss when you're out hunting. Well, to figure this out, you got your cosine cheat sheet that you're going to write down from my webpage. Sounds easy, right? Well, no, it's not easy. The hardest part about this is figuring out what angle you're at. So how do you figure out that angle at the base of this imaginary triangle for the target? Well, there's some more trigonometry here. The angle at the target between that diagonal line and the horizontal line that we imagined is exactly the same as the angle between straight out from your position. This is a new line that we haven't talked about yet. So just straight out from your position, straight in front of you, down or up to the diagonal that you're looking at the target. Now, the reason is if you imagine, bear with me here, if you imagine another triangle kind of with the two diagonal lines meeting with the first triangle we talked about. So it makes like a rectangle. Again, I hope I didn't lose you there. But if you just take like a mirror image of the triangle and flip it over that diagonal line, trigonometry tells us that the opposite diagonal angles are the same. So the angle from you looking straight out down to that diagonal line, or straight out and up to the diagonal line, depending if you're shooting up or downhill, is actually going to be the opposite and equal angle down to the target. If I just confused you, forget what I just said and just trust me. Don't even worry about the trigonometry. Just trust me that whatever angle you're shooting off of straight out in front of you. So straight out in front of you we'll call 0, and then up or down 5 degrees, up or down 30 degrees, whatever that angle is, you multiply it by that angle's cosine, and you will end up figuring out the horizontal distance. You don't even have to know why. You could just do it. Okay? Now, measuring the angle by eye is very difficult if you don't have a whole lot of practice doing it. I have many sniper students that bring up to a hill, and the first thing I would do, looking down the target, say, okay, everybody, before you actually measure, everyone take a guess right now on how many degrees down below us that target is. And most students, when the target was only 30 degrees below us, would guess 45 degrees or more. I don't know why, but for some reason in our heads, we just imagine angles being bigger than they really are. Well, it's really hard to find a more than a 30 degree angle. That's kind of why I keep using that number. And that's because mountains generally tend to be about 30 degrees. And you ever notice in the distance when you look at a mountain range, look at the sides of all the mountains. They all should be about the same angle from each other. Or go watch an old Bob Ross how to paint video on YouTube, and you'll see when he makes the mountains, he's going to make them with similar angles, because that's naturally when the ground starts to slough off. When you go to a construction site and you see a bunch of piles of dirt, do the same thing. Look at them. All the piles are going to have about the same angle on them. That's not because they took the time to stack them that way. That's just because when you pile general just ground or dirt up, it'll get high enough until it starts to slough off and fall off on its own. And here's another trivia nugget that you can forget if you want. It's called the angle of repose, the angle at which things will naturally fall off and tumble on their own. Well, it's about 30 degrees when you're dealing with dirt. So that's why it's harder to get steeper than 30 degrees, because most mountains aren't that way. You really got to be on a cliff to be able to see that difference. Well, when you're getting your angle measurement and you learn the angle of repose is 30 degrees and you know to expect most likely what you're doing is less than 20, you need to know that angle first, of course, and then you need to know the distance to the target, that diagonal line. So to keep things straight, I like to call the distance to the target distance, and then that horizontal distance, the angle distance. Okay, that's just to remind me that it's a corrected distance. So in the example I just gave you with the 800 yards and the 30 degrees times the 8.866 cosine with an answer of 693 yards for that horizontal, what I would say is that I have an 800 yard target distance, but a 693 yard angle distance. So I can keep the numbers separate. Well, so back to measuring real quick. So again, most guys, they put their arms straight out down at the target and they estimate way too much. You can use a few tools, one of which is a mil.master, which I highly recommend. I'll put a link to it on this show's page. And if you want to go get one on Amazon, you click through the link. I think I get a couple pennies to help support the podcast, so I'd appreciate it. I like having a mil.master. They have a graduated graph on the back that you can tie a string with like a fishing weight to it. And by putting the mil.master on your scope cap while you're looking through your scope down at the target, or you can even look down the edge of the mil.master, the string will hang and tell you what degree you're looking down at. Well, another thing you can use is some compasses. Some compasses have a little angle indicator in there where you can hold the compass up and look down the edge. They do that for estimating avalanches and things like that. You can use that to measure the angle. You can even, on these modern laser rangefinders, heck, your iPhone has an angle measurement in it you can use if you really want to. But some of these modern laser rangefinders not only will tell you the angle you're looking, they'll do all this math for you. Some of these laser rangefinders will tell you when you look down at the target. They'll say 800 yards, true or target distance, and 693 yards, angle distance, because they can do the math for you already, and those are pretty slick. But I want you to still know how to do it on your own. Another tools I use are like an angle cosine indicator. It's a really slick little device that just mounts right on your scope body. And when you're looking at the target, you can just look through your non-dominant eye and look at the reading right on the angle cosine indicator. Instead of giving you the actual degrees to the target, it just gives you the cosine. Because really, the only reason we want the degree anyway is to reference a chart with a cosine. So they were smart enough just to give you the cosine right off the bat. So that's kind of cool. So there's a lot of ways we can measure the angle down to the target to convert our target distance into our angle distance. Now, the reason I'm giving two different names to these, and the reason I'm not just having you forget that original target distance, in my example of the 800 yards, is because although we're going to treat the target as if it's only 693 yards away in this example, for our elevation, because of gravity is what we're talking about here, I need to treat the bullet as if it's traveling the entire 800 yards when I'm working on wind and other factors. Because it's true, the bullet really is flying a full 800 yards. So if the wind is a certain speed and it's going to affect the bullet more over 800 yards than 693, which it will, I just got to remember that 693 is only for elevation. Spin drift, air density calculations, wind calculations will all need to be done at the actual full distance, because that's what the bullet's really doing. So, apologies if imagining triangles and angles and everything is difficult here. The takeaway simply is, if you don't compensate for the angle, the bullet's going to impact higher than you expected, because it's not going to fall as far as you expected. And the way you compensate for the angles, you figure out the angle up or down you're shooting off of level. You take the cosine for that angle and multiply it by the distance that you actually are looking to the target. And that'll give you a new number, which will always be smaller, to pretend like the target is away. So you'll use your elevation for that smaller number. So I hope that helps. I take that some of the mystery out of it. When you're hunting, you can just look at this math and realize, 86.6% of the distance at a 30-degree angle. You're shooting 100 to 200 yards. Just aim at the bottom of the kill zone and you'll be fine. You're talking a matter of inches. You cannot worry about it. But further out, you're really going to have to calculate and take that into effect. And you'll forget to take it into effect until you shoot over a target and you remember later and you can do it. Well, I have some time left, and I mentioned I might talk about what happens when the rifle is canted to one side or the other. It's bad. When you cant to one side or the other, not only does it affect the bullet, but it's going to do it inconsistently. Not because it's different every time you shoot with the rifle at the same angle, but rather, once you are a shooter that is shooting with your rifle at an angle, it's very hard to keep it at the same angle. So it's it's common to see it angled one shot, straight up and down the second shot, and on the third shot, it's angled the other way. So that's why it's inconsistent, because it throws the bullets all over the place. So let's talk about why that happens. First, your scope is above your barrel. You can't look through your barrel and see the target. We'd love to, but there's a bullet in the way. So we have to put a external aiming device on top of the barrel. Well, imagine looking at 100 yards. Excuse me. If I was more of a professional podcaster, I would edit that yawn out, but you guys are going to hear it in its full glory. Sorry about that. You're shooting at 100 yards. Your scope is looking straight at the target. Your barrel is not pointing straight at the target. It's pointing up a little bit. Let's take it out even further at 500 yards. Your scope is looking straight at the target. Your barrel's angled up quite a bit to allow the original path of the bullet to be pointed up in the air, so that as it falls off that original path, it can come down and meet the target. Your bullet's going to cross your line of sight twice. It's going to come out of that barrel and cross your line of sight up close. It's going to fly, kind of not really fly, but it's going to travel in an arc to the target because it's falling as it goes, and it's going to come back down and meet your line of sight again at the target. Well, so that upward elevation of that barrel is necessary to compensate for gravity. If you were to just take the angle out of the barrel and instead have the barrel be perfectly flat with the ground, your bullet's never going to hit the target, because as soon as it leaves, it's going to start falling, and it's going to fall away from that path and hit low or completely miss. Well, it's important to think about that angle there, because now what happens when you lay your gun on the side? Let's take it to an extreme again, like we did with the shooting up or downhill. Let's say we're going to lay the gun completely 90 degrees on its side to the left. So we're going to tilt the gun left, put the scope on the left of the gun, and try and shoot the gun that way. Imagine what's going to happen. I just told you the angle of the barrel is important. Well, if the barrel was angled up when we were shooting normally, we tilt it all the way to the left. The barrel's doing two things different. Now it's going to be pointing left, right? Because it was pointing up, and as you pivot it to the left, it's not going to point to the left. It's going to point to where it crosses your line of sight from the right side to the left side now, instead of from the bottom side to the top side. So not only is the barrel pointing left, but it's also going to be level with the ground, because it no longer has elevation up away from the ground. Which means if you laid the rifle on its left side and you shot at a target without making any adjustment for the rifle being canted, you're going to miss low and left. Going to miss left because that's the direction you're shooting the bullet with the barrel at an angle to the left. You're going to miss low because you now no longer have the barrel compensating for gravity and angling up. Well, that's the extreme level. Well, everything in between still affects it, maybe just not as much, but you're shooting at 1,000 yards. With some calibers, that's a 6-inch difference with a 1 degree change of the rifle. Well, that's why a lot of guys have bubble levels on their scopes from their rifles, and I think they're a cool tool to have, and I need to get one, but I don't know. I'm old school. I've never had one on there. But also part of the problem is even the guys that have them, I can reach out and grab their bubble level and wiggle it with my fingers. If I can wiggle it with my fingers, then there's no way it's accurate to 1 degree, which is what's going to make the difference at distance. Even a conversation on how much change can the human eye actually even see in a bubble level. Can you see a 1 degree change enough to even notice? So I'm sure they're helpful. I probably should get with the program and start using one, but I'm just used to shooting the rifle up and down. You can compensate for this angle. So you can actually do the math, and we can cover that in the future, on how to dial to compensate for the distance. Or if you're shooting, let's say at 100 yards, I have a neat little trick. Imagine, if you will, shooting at a 8-inch target. For the military police snipers, that's, I don't know, I'm guessing about a normal head size. Mine's bigger than that. I got a big noggin, or a kill zone on a deer or an elk. Let's call it about an 8-inch, kill zone. If you lay the rifle completely on the left, and sometimes, especially in tactical situations, you need to do this to be able to get low enough to shoot under something, or through a certain loophole in a wall. If you lay the rifle completely on its left, and you bracket the target with the crosshairs, you can actually still hit it. So what you do is you take what is now the horizontal crosshair, used to be the vertical crosshair, but now you lay the scope on its side, and you rest it. Not really, but visually, you rest it on top of the 8-inch target. And then you take the now vertical reticle, which used to be the horizontal reticle, but now it's vertical, and you bracket it, or you put it on the right side of the target. So what you end up having is, if you look at your scope, you kind of have 4 quadrants. You have your up and down and side-to-side reticles, and you have your 4 regions of the scope that are split up by that. What you end up doing is you take the target, this 8-inch target, and you put it in the bottom left quadrant of the scope, but you move it all the way up to where it's touching each reticle. So it's touching, the top of it is touching the now horizontal reticle, and the right side of it is touching the now vertical reticle. By bracketing in there, what you end up doing is you compensate for your few inch left and your few inches low you're going to end up having. So let's say for a 308 or a 30-06, something like that, you're going to have 3.5, 4 inches about of a drop, and about 3.5, 4 inches of the bullet going to the left. And that makes sense, because the bullet should go exactly far to the left as the drop, because that's the whole point of the barrel being at an angle anyway. And that'll bring you right into the center of the kill zone. So it's a real quick way to turn the rifle to the side, just bracket that new 8-inch target, and you'll be good to go. You should go try it out. So I hope this helped. I haven't done one of these just pure lesson, format podcasts in a while. I hope you guys enjoyed it. Keep the feedback coming. Keep questions coming. There's an entire section of my book dedicated to this, so please keep supporting the Long Range Shooting Handbook. I really appreciate it. I am just so far behind on the advanced edition. I apologize for those of you that want it. But I thank you all for the support for the Long Range Shooting Handbook so far. It's still #1 on Amazon. It's been, 11 months now. I'm going to SHOT Show and signing it. That's awesome. I'll probably have about 17,000 copies sold in the next couple of weeks for SHOT Show, which just blows me out of the water. And the charities that you guys have been supporting are just so stoked that you guys have been so great with the book. So I appreciate your support. I appreciate you listening. But to do something in exchange for me, give me the feedback. Let me know what you're like and what you're not, and give me those questions, and spread the word. You like the podcast, like it on iTunes, subscribe to it. You like what I have going on for all the articles and the books and all the everything else. Go to the Facebook page, go somewhere, leave a good review. I just really appreciate it, guys. Keep up the good work. Check out all the show details at goingballisticpodcast.com/16. That's 16. And I hope you guys have a great new year. This will be the first podcast of 2017. So get out there, get to the range, be safe, and I'll see you guys next time. Take care.